Hi, my name is Kimi Aldash. I work in MACE. I'm the Net Zero Carbon Retrofit Team Manager. So today I'm going to talk to you about why our homes and buildings look like they do. So we're mainly going to focus on homes on the domestic side. And the keen focus will be on materials. So basically, let's understand what do I mean by understanding our buildings? It's what are they made of and why the buildings are different. And then when we move on to looking at the materials in a little bit more detail, we're going to be trying to understand where the materials used for the building envelope come from and how they become what we see. So let's start understanding our buildings. So what are our houses made of? Basically, it can be pretty much anything: stone, clay, steel, glass, even PET bottles, perhaps, timber, snow, just a different range of materials and combinations of these. So why are these materials the ones that are used? So before we were a globalized world and we could get materials like we have now, that we can get materials, anything pretty much from anywhere, ship it over in a container. There you go. Before these days, we were bound to local supply, whatever materials and products were available. And before we had modern construction techniques, we again were bound by local techniques. Another very important aspect of the building and why they look the way they do is because they're meant to be a response to the local climate. So what do I mean by that? So just as an example, if we have a hot climate, your home, you don't want heat to be trapped in your home because you want to be comfortable. So you want to make sure that it ventilates freely so that you can achieve comfort, and ventilation will allow the building to cool down. And you want to control how much solar ingress you will have in the building. So sun is free heat, and it also gives us daylight, which we do benefit from. So now if we're looking at a cold climate, for example, we do want to retain that heat inside our home. We don't want ventilation to cool the home down. We do want a certain amount of ventilation or air movement so that we can have good indoor air quality, but that needs to be controlled. And we probably would want to allow a certain amount of solar ingress so that we can have one free heat and still benefit from daylighting. So these are a couple of examples of the impact that the local climate would have on certain in certain areas. So these would be sort of representative buildings, and you can see that the materiality is also quite varied because it would have been depending on what was available. So let's move on to what we recognize more as dwellings. So this, for example, would be a typical, I think, 1900s Victorian mid-terrace here in the UK, which I'm assuming that everybody would have seen at some point. So we know in general what we're trying to achieve. We're a cold climate. We have to protect our building. We have to protect ourselves with our building, protect from rain and wind. We know it can get quite wet and windy here. Perhaps we don't want to protect fully from all elements. Perhaps we want some elements. So as we were saying earlier, in a cold climate, we do want to allow for some sun, some free heat, and some daylight. So what are these elements that are protecting us? So we have roofs, walls, and windows. Because again, we're a cold climate, and with development of technology, we've started adding layers to these basic elements, these protecting elements. So one of the key layers that we have added is insulation. So what it does, it's a good material to retain the heat, i.e. it makes it difficult for the heat to leave your building. So that layer is added to our dwellings and our buildings, in fact. So it helps us keep warm. We have then windows, which we control, which allow for natural ventilation. They allow us to have views out. They allow for solar gains, and they also allow for daylighting. There's a lot of aspects there that we have to combine in order to have a building. So basically, all these elements, they form our building envelope. They're referred to as building envelope, and all of them have specific functions which they need to fulfill. Okay, so that building has several materials in it. So let's look at them a little in a little bit more detail. So the first element we would have that would be protecting us or controlling some of the elements would be a roof. So what can the roof be made of? So traditionally it would have been made probably with thatch, locally available, wood shingles, common enough, natural slate these days, and concrete roof tiles are very sort of readily available examples. So thatch, timber, and natural slate. And the last one, number 4, concrete roof tiles. So what is different about concrete? So thatch and wood, they're basically natural materials and they are renewable. We can plant them again and we can use them many times over. Natural slate, it's a natural material. However, it's finite, at least in our lifetime. So once we've used up all the slate, there's no more, that's it. And concrete, it's actually man-made, so you can't find concrete in nature. We put a whole bunch of elements together and we make concrete, which we're going to be looking at in a bit more detail later. So the other element to protect our buildings, to form our building envelope, is the wall. So again, several different types of walls that we can have. So we can have a brick wall, we can have a concrete wall, it can be a stone wall, or it can be a building clad in timber. So for all of these materials, they aren't on their own. There's sort of layers behind them that help them sort of be structurally sound and things like that. So, but these are sort of some of the very common elements that we do see exposed. So again, concrete we've been talking about already, so we know that that is timber and stone. We also are now familiar with. So what is different about clay? So brick is made out of clay. It's a natural material, however, it is finite. Concrete, as we discussed, man-made. Stone wall, stone, it's natural and finite material. And timber, as we mentioned before, it's natural and renewable. But what's different about brick? As much as clay is actually available in nature, we need, in order to get the brick to have certain properties that we need it to have, we have to process it so that it's stable and it can take the loads and things that we need it to do. So we will talk about that in a little bit more detail soon. Remember, I also was saying that we added a layer to our building envelope that dealt mainly with trying to retain the heat inside our homes. So these are 3 examples of what those materials can be. They're called insulation. They're insulant materials. So you can have it from sheep's wool, rock wool, or wood fiber made out of timber. So they are very much what it says on the tin: sheep, rock, and timber. So windows, which is a very important aspect of our buildings and our homes. They provide us with views out. They allow us to control the ventilation. So we open them, close them. There's a variety of ways how we can do that. So they can pivot, they can slide, they open halfway, they open just a little bit. Different range of operabilities that they have. So as we started adding those insulent materials to our walls, windows became a weak point. Problem being, insulent materials are not transparent, and we need the windows to be transparent because we want the sun to come in, we want to be able to look outside, and we want daylighting because we don't want it to be dark. So again, as technology started developing, what they've done is add more layers of glazing. And I'm sure most of you would have heard of double glazed windows or triple glazed windows. And basically all that is that you have 2 layers of glass or 3 layers of glass with gas inside. So how do these materials become? Where are these materials from? These things that we see every day when we're walking in the streets or when we're inside a dwelling or work or school. So glass, very common material, very important because of that transparency and the ability to stop wind and rain coming in and gives us sun. So sand is basically the basic product for getting glass. So sand is processed in a very complex way, which we're going to summarize very simplistically into saying that glass basically is sand heated to significant temperatures. We're talking 1600 degrees Celsius. So basically sand and energy, a lot of energy, becomes glass. Bricks, which we mentioned before, that story about the clay being processed in order for us to have bricks. So again, hugely complex process, but if we're going to summarize it, again, very simplistically, we need to add water and a lot of energy. So bricks can be fired at 1200 degrees Celsius, and then we get bricks. So it's not just bricks on their own, because if we just pile a whole bunch of bricks, one, probably still get wind coming in, you'll probably still get rain coming in. And if someone just walks path and just pushes the wall, it probably is going to fall. So it's not very safe. So what they've added this glue, which is called mortar, which bonds the different bricks all the bricks together and makes them act as one. It also stops or reduces the capability of rain coming in and wind coming in, if it's well done, obviously. So what is mortar? Mortar is made out of cement. So cement is the base product for a couple of very important products that we're very familiar with. So cement, as the other materials we were talking about, it goes through a very complex processing. But again, if we're going to summarize it, basically we get limestone from a quarry, silica, combination of different components, and we throw a lot of energy at it. All of this comes together and creates clinker, which then you mix with gypsum, again, coming from a quarry, and that's cement. So remember we were talking about concrete earlier. So concrete, and I'm sure you would have heard like concrete has a lot of carbon, it's very energy intense. And the reason why, it's because it has cement. Because concrete is technically a simple enough material. It's just the cement, which is complex, with a mixture of sand, stone, which in this case is called aggregate because it has a specific size, and water. You mix all of that together and you get concrete. So you can mix these in different proportions to get different grades and strength of concrete, but it's simple materials outside of cement, obviously, which is it's a complex process and very energy intense. So let's look at the insulations, the insulation materials. So we know the original material from it, again, processed. But if we go and we reduce this very simplistically and we look at it, for rock wool, we're using rock, which is heated. So a lot of energy goes into it. It's spun, and then you get you form it into slabs or wool, as you may. Wood fiber, same idea. So we use, but it's made out of timber. It goes through a process. However, this process isn't as energy intense as all of the ones that we were looking at so far. So you take the timber, make it into wood chip, which can be used from other processes. They're steamed, they're dried at specific temperature, 180. Before we were talking at over 1,000 degrees Celsius. So now we were talking 180 degrees, so significantly less energy. It's bonded and pressed, and that's wood fiber. And last but not least, sheep wool, which comes from sheep, quite simply. And again, even less processing is used for sheep's wool. So basically, you remove the fleece, which the sheep will grow back again, so it's a renewable material like the timber was. Sheep are not particularly clean, so give it a wee wash. Let it dry out. Layer it, which is the processing aspect, and you have sheep's wool. So these last three, like they all perform the same function of trying to keep heat inside homes, but they have slightly different properties, and they do that in slightly different ways. And they need different sort of support aspects for the construction. That's why you would choose between them. So basically, I hope that after this very brief and summarized presentation, you have understood why our homes look the way they do as the response to their local climate, very much so, and the availability of local materials, which now has shifted a little bit, but it's something perhaps we want to be considering going back to with the climate conditions, that situation in which we're in. Hopefully you have been able to understand why we're using these different materials and the specific characteristics which we need these materials to have in order to select them to fulfill the specific functions of forming that building envelope. So what I hope now everybody has taken from this is that you will start looking at buildings with a slightly more inquisitive eye and questioning, why is it this shape? Why do you have these elements? Why does this material look like this? Why is this material in the wall or in the roof or on the floor? Thank you.